Intermediate Algebra for Statistics, Using Elimination to Solve Systems, Part 2. Lesson Objectives: Use elimination to solve systems of linear equations. Compare 3 ways to solve a system. Example 4. Solve the systems 1/3 x minus 1/2 y equals 1/6, 1/5 x plus 1/4 y equals 13/20. Solution: to clear the fractions in equation 1, we multiply every single term by the least common multiple of the denominator, which turns out to be 6. To clear the fractions in equation 2, we multiply everything by the least common multiple of 5, 4, and 20, which turns out to be 20. We have to be sure that we multiply every single term in the first equation by 6 and every single term in the second equation by 20. So for the first equation, we are going to have 2x minus 3y equals 1, and for the second equation we have 4x plus 5y equals 13. The fractions are eliminated. Now, because the x's, the y's, the equal sign, and the constant numbers all line up, elimination would be the easiest way to solve this system. So we could eliminate either the x's or the y's. I'm going to choose to eliminate the x's. To eliminate the x variable, I'm going to multiply the first equation by -2, and that will make this term a -4, and a -4 plus a +4 is 0. So the x terms will be eliminated. So equation 1 will become -4x plus 6y equals -2. Every single term gets multiplied by -2. Now we add the two equations up. We get 11y equals 11. And solving for y, we get 1 as a result. Now to find x, we substitute 1 in for y in one of the equations and we solve for x. So we have 2x minus 3 times 1 equals 1. That becomes 2x equals 4, and x is equal to 2. So our solution is 2, 1. Example 5. Solve 6x minus 2y equals -12. -3x plus y equals -4. To eliminate the y terms, we multiply both sides of the equation 2 by 2, and yielding the system 6x minus 2y equals -12, the first equation, and the second equation will become -6x plus 2y equals -8. Now that the coefficients of the y terms and those of the x terms are equal in absolute value and opposite in signs, we add the left sides and the right sides of the equations. So this is going to become 0, and this will become 0. And we are left with a false statement. 0 equals -20. Since 0 equals -20 is a false statement, we conclude that the system is inconsistent and that the solution set is the empty set, which means there's no solution. Inconsistent systems of two equations. Property: if the result applying substitution or elimination to a linear system of two equations is a false statement, the system is inconsistent. That is, the solution set is the empty set. If we think of this graphically, this is lines that are parallel. They do not intersect. Example 6. Solve 2x minus 7y equals 5, 6x minus 21y equals 15. Solution: to eliminate the x terms, I'd take the first equation and multiply it by -3. That would make this term a -6x. So the first equation will become negative 6x plus 21y equals negative 15, because every term gets multiplied by negative 3. And then we add that to the second equation, which is 6x minus 21y equals 15. Now let the coefficients of the x terms, and in this case also those of the y terms, are equal in absolute value and opposite in signs. We add the left sides and then add the right sides of the equations. So this will become 0, this will become 0, and negative 15 plus 15 becomes 0. So we are left with 0 equals 0. The x's and y's are eliminated. Since 0 equals 0 is a true statement, we conclude the system is dependent and that the solution set of the system is the set of order pairs that represent the points on the line 2x minus 7y equals 5 and the same line 6x minus 21y equals 15. So if we think of this graphically, the first equation and the second equation will make the same graph, and graphing these, the two equations would coincide. Dependent systems of two linear equations. Property: if the result of applying elimination to a linear system of two equations is a true statement, and that's one that can be put in the form a equals a, then the system is dependent. That is, the solution set is all the set of order pairs represented by every point on the same line. Thanks for watching.